This is 8.6, day 2, simplifying rational expressions, and we're going to introduce rational exponents in this lesson. There is a definition here, you don't need to write it down. A rational exponent is an exponent that can be written as m over n. So if you look below on this smartboard slide, this is what I do want you to write down. You can convert from a fractional exponent to radical form in the two equations below. So this is called a fractional exponent. So it has a base of a raised to a power of m over n. You can convert it back to a radical. Be careful where you put the pieces. The base goes underneath. The m also goes underneath now as a power. And then this denominator is written as its index. You can also rewrite it in the bottom equation. Again, the a goes underneath. The n is still the index, but notice the difference. Now you can raise it to a power. So please make sure you write those two equations down, and then we'll practice it on the next slides. All right, first example. We want you to convert these fractional exponents to radicals. So example A, 2 raised to the 6/5 power. So you want to write it as a radical. So the 2 is your base, then the 6 is your power, and then remember that denominator is your index. Then you try to reduce it if you can. In this case you can. This is a 5th root, so you can rewrite 2 as 2 to the 5th and then 2 to the 1. So then 2 to the 5th, there's 5 of those 2's. So 5th root of 2 to the 5th is 2. That's going to go out in front. And then you still have left a 2. Next example, 2 raised to the 3/5 power. Rewrite it as 2 is your base, 3 is your power, and then your index is that denominator 5. So 5th root of 2 cubed, you can't reduce anything further besides just rewriting 2 times 2 times 2 as 8. So now you have the 5th root of 8. Next example, write the expression in radical form. So just some more examples. So 64 raised to the 1/3 equals what as a radical? So 64, first power, and then cube root. And now you try and rewrite 64. 64 can be rewritten as 4 to the 3rd, and then 3rd root. So your final answer is 4. Next example, let's go ahead and have you watch. Negative 32 raised to the 3/5. So you have negative 32 is your base, raised to the 3, and then 5th root. Remember that second equation? You can also rewrite it like this. Negative 32. And then I'm going to put that 3, that index, out here. And you'll see why in just a moment. And then 5th root. So now I can rewrite 32 as negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Negative 2 to the 5th is 32. 5th root, and then way out there is that 3. What happens is that negative 2 to the fifth root, is -2. And then we still have that 3. So -2 times -2 times -2 is -8. So sometimes it's easier to rewrite it with the power outside the radical. All right, let's try this one. Go ahead and write it down. 4 raised to the 5 halves. So 4 is your base. 5 is your exponent, and then 2. Now let's rewrite it again like we did on the last example. So we have 4, and then we have it all raised to the 5th. It's easier now in this example to write like this because the square root of 4 is 2, and then raised to the 5th is still there, and then 2 times 2 times 2 times 2 times 2 is 32. All right, this example looks a little different. It has 27ab cubed raised to the 1/3 power. So let's rewrite this first expression, the 27ab cubed, as a radical. The 1 power is still just raising this to the 1. And then the denominator, remember, is the index, so that's 3. And then we still have it over here, cubed root of 5a to the 4th b. Now remember in our radical rules, we have 2 radicals that are both index of 3. So we can combine them into 1. So we have 27ab cubed times 5a to the 4th, and then b. Now we try to break down the terms so that they're in groups of 3s or raised to the 3rd power. So 27 can be written as 3 cubed. And then we have 5. And then we have 5 a's. So I'm going to split up as a cubed and a squared. And then I have a b cubed and then a b left. Now the things that are going to pop out are anything that's raised to the 3rd power. So 3, a, and b. So those will go out in front of the radical. Because the cubed root of 3 cubed is 3, the cubed root of a cubed is a, the cubed root of b cubed is b. Now what's left is the pieces that are not cubed. So now we have cubed root of 5a squared b. Just a couple examples left. Now we're going to do the opposite. We give you a radical, and we want you to convert it back to a fractional exponent. So 13 is my base, 4 is my power, and remember where the index goes? The index goes in the denominator. Now we just reduce that back down to 13, and then 4 divided by 8 is 1/2. Question B. 13 is my base, 15 over 5, 5 is my index, so that goes in the denominator, and then 15 divided by 5 is 3. Couple more left, same type as the last examples. Rewrite as a fractional exponent. So 81 is my base, 3 is my power, and remember that index of 4 is my denominator. Example B, 10 raised to the 9 over 3. The index is always your denominator. And then 9 divided by 3 is 3. Last one, 5 is my base, 2 over 4, which is 5 halves. I'm going to save these word problems for the next video.